Right, this is question 3 now. Let's see what it says. It says black and white bitmap images can be used to encode 1 to represent black. So if I was there, I would be thinking, say, black equals 1, and white and 0 to represent white. So white is 0. So writing that out there sort of brings our eye to it very quickly. Don't have to reread the text again. The algorithm in figure 3 down here calculates the number of black pixels. So in other words, it's going to count the number of black pixels in a bitmap image stored in a 2-dimensional array called image, which has 4 rows and 3 columns. So basically, 4 rows like this and 3 columns like that. So this is our bitmap image. 4 parts of the code, L1, L2, L3, and L4 are missing. Okay, so basically we've got to try and understand what's going on here in order to calculate the number of black pixels. Well, let's try and sort of figure this out as if we were doing it without looking at this algorithm. What would we do? Well, we typically go along and count them. So let's say, for example, this one is black, this one is black, and this one is black, and perhaps this one is black. Let's just say, for instance, if I went through and I was counting how many black pixels by eye, I'd go, there's 1, so that's 1. That one isn't. This one isn't. This one isn't. This one isn't. That one is. So that makes 2 in total now. This one isn't. This one is 3 in total. This one isn't. This one isn't. This one isn't. This one is. So that's 4 in total. I'm sure you would agree that's how you would do that, right? So basically, this variable hopefully is self-explanatory because they are using well-named variables. This is the number of black pixels. So these lines here are basically initializing some variables. So that's sort of initializing. And the number of black pixels is what we need to calculate. Now, if we haven't started going through the at this stage, we haven't started going through the 2-dimensional array yet representing the bitmap. So therefore, the number of black pixels, we haven't counted any yet, right? So therefore, this must be a 0 here because we haven't got any yet. So the answer to L1 is 0. Okay, now we've got to look at L2. Shade 1 lozenge to show which operator should be used in L2. Right, okay, so what does this do? Notice it says x is 1, and while x, what do we think about x? X is number of rows. Remember the rows are going this way. Okay, so we're using x to represent some variable that's going through the rows. 1, 2, 3, 4, basically. So we want to keep x increasing until it reaches the number of rows. So we want this x to be less than or equal to the number of rows, because obviously the number of rows is 4. We want x to be 1 to start with, then 2, then 3, then 4. So less than or equal to. So that's why I filled in less than or equal to down here. Okay, the next bit, I'm just going to take a screenshot of the algorithm here, and because I'm going to turn over the page and we want to be able to see that at the same time. In your case, you'd have it in front of you. So let's have a look at the next one. Shade 1 lozenge to show which should be written at L3. Well, let's try and figure out what's going on here. It says if, so we're doing some sort of decision. This is our 2-dimensional array, and it's talking about some position in the 2-dimensional array. This is the row number, this is the column number. And we're saying if it's equal to some value that we've got to figure out what it is, then we're increasing the number of black pixels. Okay, so we're increasing the number of black pixels. What did we say earlier, which was black? Well, if you go back here, we said the black was 1. So if we come across a 1, so basically what's getting stored in here representing, let's say the image that we've got there, is 1 0 0 0 0 1 0 1 0 0 0 1. That's basically the same representation as this. This is shaded in to show black pixels. This one is ones and zeros. Ones for the black, zeros for the whites. So basically, this is incrementing the number of black pixels. So what must we have got in the two-dimensional image in order to have got a black increase the black pixel? A black pixel, right? What is a black pixel? It's a number 1. So therefore, the answer to this is number 1, because black is number 1. Right, finally, shade 1 lozenge to show what code we should be in L4. So what does L4 do? What is L4 doing? Let's have a look at, well, L4 is represented as the value of this variable called y starting at 1, and y is less than or equal to the number of columns. So this is basically the column counter. Okay, so what are we doing when we're going through this thing is we are going through with the row starting at 1, and then when we've gone through the whole of one row, we're going to increase the column. So then we're checking this one first, then this one, then this one, then this one, then we're going over to here, and then we're checking these. So basically what we're doing here is increasing the column count from being 1 to 2, and then when we've checked all the rows in this column, we're going to go to the next column, column 3. So this is increasing the column count. Well, the column count is y, so this therefore should be whatever y is plus 1. Okay, so we're increasing the y value, which is the column count, by 1. And that's why I've circled this lozenge. Y is y plus 1.